Okay, first, I'd like to introduce Professor Robert Hairstans. He's head of the Center for Offsite Construction and Innovative Structures within Edinburgh Napier University's Institute for Sustainable Construction. His expertise is in the fields of timber engineering and technology. He's authored over 40 peer-reviewed published works in journals, books, and conference proceedings, including 3 books on the topics of wood-based offsite construction. He's also academic lead of a company. It's Offsite Solutions Scotland, a company formed by 10 timber offsite industry partners in 2016 with a combined manufacturing output of 170 million pounds. In dollars, I'm not sure where that would be, probably about 250, something like that, 250 million, employing more than 1,000 people.
Yeah? Okay, first off, just to thank, in the first instance, Peggy Clouston for putting me in touch with yourself, Art, and for Forest Economics giving me this opportunity to speak at this forum today. So thank you very much for that, and thank you very much for attending this afternoon. And I think why this is important to me personally is I've spent my career in offsite construction and industrialized timber. So to address this forum today is actually something that's, it's not quite bringing a tear to my eye, but I'm probably quite close to emotion. So thank you very much for this opportunity. But as much as I've spent my career in offsite and industrialized timber construction, it does precede me by quite some distance. And we can go all the way back to even medieval cruck frames being pre-manufactured in the yard by carpenters in order to create and to mark these systems up such that they could be put up on site with a degree of efficiency and quality assurance. In the UK, we had Manning Cottage, which was exported in the 19th century for colonial expansion in Australia as a result of a skills deficit and the need to deliver affordable housing solutions. And of course, here in the United States, we had balloon framing, which then became platform framing as a result of mechanization and new technologies like the nail gun. And we even have Isambard Kingdom Brunel get into the act with the hospitals shipped for the Crimean War, flat-packed and sent out there as a result of the necessity to provide shelter. So there is a historical context to this, and there was drivers at the time which necessitated an offsite and industrialized timber construction approach. Those drivers have obviously moved on, in a sense, but we still have cruck frames. We just have CNC machining driven by computer-aided design and computer-aided manufacture. But we also have things happening like, the tallest timber building and timber reaching new heights with respect to this, and this has been touched upon already with engineered timber products and mass timber. We have robotic collaboration, we have AI, etc. And with robotic collaboration working with humans is actually pushing the boundaries of even the structural engineering behind these systems and starting to challenge some of the regulatory drivers as such. And we have North Scot, at the very top of Scotland in Wick. So if you know Scotland at all, that's up near John O'Groats. And they've invested in virtual reality and augmented reality. And the reason for them doing so is in order to inform the client and the consumer as to what that final house type would look like. So digitization is obviously affecting the delivery modes of offsite and industrialized construction. So the drivers, in a sense, have changed over a period of time. Really interestingly, what we have at this moment in time is a swelling urban population and the need for housing and shelter with respect to that. It's been spoken of today in terms of the stagnation of productivity in construction relative to other industries. We have movements in that sort of global market in terms of the growth, the potential growth of construction. But if we think of what that's offset by and the use of non-renewable resources, and ultimately what that would mean to the environment if that productivity actually went up, then what would that mean in terms of the future and our future generations? And I personally have young kids. So to my mind, we need to think about the tipping point, and we have to think about the utilization of natural resources and indeed timber and wood within the delivery of that built environment in order to sequestrate carbon. because it's fundamental to future generations and sustainability. As much within the US, we have obviously what's happening in the UK. In the UK market, a 90 billion construction market. And in many respects, there's a government-driven agenda now behind off-site construction, and we can see some major investments going in that respect. We have obviously Sekisui investing, we have Top Hat, we have Legal in General, etc. And the UK Construction Leadership Council has 3 sort of focus areas in digital, manufacturing, whole life performance, which all resonate with industrialised timber construction. And obviously there's these sort of 4 key drivers as well that the UK government are looking at with respect to that strategy 2025. And important to that is improvements in exports, and that's actually about reducing the import gap. And then we have the Scottish context, which is quite interesting in response to that much larger sort of UK market. And we have a historic backdrop of off-site construction and industrialised construction, largely focused on timber off-site construction, largely focused on panelised systems, and 85% of our houses are delivered in that manner. So the key point I wanted to address there was the drivers now are slightly more complex. We have sustainability, the necessity to change construction culture to be less adversarial and to get more diversification. We need human capital and the skills that underpin it. We need to improve productivity, but we also have to think about the productive use of land and not just output relative to input. We have to think about digitization, and we have to think about the regulatory drivers as well, and how those drivers correspondingly intersect and play out to the right form of construction, an off-site system, whether it be a sub-assembly, pre-manufactured, volumetric unit, enhanced panelised system, or indeed a hybrid type solution. So it's key that we think of those drivers and the intersect of them with respect to our decision-making process. So that's very much what I try to instill in the work that we do at Edinburgh Napier University. And the research centre that I run is very much about applied research, creating impact to deliver these sustainable communities of tomorrow. But fundamentally, it is underpinned by student talent, because that is the next generation, and that's who will ultimately deliver that built environment. And we do that through something called a Built Environment Exchange, where we articulate students onto a program and then give them opportunities. And one of those opportunities is something we call Augmented Learning. And within that, over the last 2 years, we have collaborated with Harvard Graduate School of Design and their student cohort, and we've taken them on a learning journey throughout Scotland. And through that learning journey, we went to different destinations and focused in on each one of those drivers. So through the lens of each of the companies, we have looked at each of those drivers. So I'm going to take you through that learning journey pretty quickly, but hopefully I'll give you a sense of what they learned. We visited CCG in Glasgow, £12 million investment in off-site pre-manufacture, semi-automated mechanisation, and was taken around with one of my ex-students who's now employed there. We focused in on human capital because obviously they're looking to increase their output relative to the market. And with respect to that, they obviously recognise the necessity for skills from the factory floor to leadership at the top. And they worked with us in collaboration with one of their competitors in Stuart Milne Timber Systems and developed skills material in partnership with ourselves to address both the factory floor and also on-site installation through video and animation content and creating modules. We recognise the need to push that out wider into the community and correspondingly created generic learning content which was endorsed by the Royal Institute of British Architects. Fundamentally, what was key within all of that, though, was really that collaboration, and we developed a methodology for collaboration. And where that methodology took us was, as Art spoke to, the creation of Offsite Solutions Scotland, which is a cooperative of off-site operators, all industrialised timber construction, the length and breadth of Scotland collaborating towards scale. We're academic lead. It links in with Scottish Enterprise and the Construction Scotland Innovation Centre and creates opportunities for further supply chain integration. As part of our visit to CCG, we also visited a site in Riverford Gardens. And in this instance, still on this sort of skills piece, we're actually looking at the harmonisation of the new regulations, the European Code of Practice, and the standardised detailing that we created working with CCG to allow closed panels to be received on the site while still ensuring that those systems could conform to the stability requirements, i.e. Eurocode 5. So you can see some of the standard details that were evolved, and you can see those coming off the production line. So that was the first case study. That's Riverford Gardens. It's a 3-bedroom semi-detached house type in Glasgow. We then returned to Edinburgh, and we went on we had a mass timber seminar. And CCG, again, were one of the key delivery partner behind Yoker, the tallest timber building in Scotland, of a mass timber solution. But in this instance, the mass timber seminar in the first instance was more sort of thematic, where we wanted to cover the genetic content around mass timber systems, and not just look at the glued systems of CLT and glulam, but also look at the non-glued systems of dowellam or brettschappel, and how you can use the moisture movement in dowels to lock together lamellas to create a structural system, and also look at things like nail lam as well, which uses aluminium nails to facilitate CNC machining. So we covered all these different products, and hopefully informed the students as to how these different products could be utilised for varying contexts relative to the quality assurance and performance attributes. What we further did was then zone in using, again, case study content. And in this instance, we looked at a project called Multiply, American Hardwood Export Council, and the utilisation of tulip wood for Multiply. That was a Wathistleton architects-led project, or design project with Arup Engineering. But interestingly, it was a Scottish supply chain that carried out all the product pre-processing of the material, the manufacturing of it at the Construction Scotland Innovation Centre, and we undertook the quality assurance test work. So at the Innovation Centre through in Glasgow, they have a vacuum press, which allows not just CLT to be made, but other bonded systems or bonded timber systems such as glulam, because of the flexibility of it. And our role within that was to ensure the quality assurance of the material. The moisture content of the lamellas respected with each other, and also the grading of the material as it's being utilised within it, and overseeing things like priming of the hardwood species to allow the bonding to take place. Once these panels were manufactured, we took a subset of that material, and we carried out a series of tests to ensure the finger jointing was of strength requirements, the bond strength, including roll and shear, bending out of plane and in plane, and then we compared that relative to the European product, and you can see how the tulip wood CLT compares to the standard European product for in-plane bending, i.e. when it's acting as a beam. And obviously all of that content then informed the third case study or the second case study rather for the GSD students. So they got informed of all the technical attributes that sat behind it. The next step on our journey, we travelled north. We went up to Fife. And in this instance, we wanted to look at the cultural driver and the cultural aspects of construction. And Falkland Estate is a really interesting culture. So Falkland Estate in Scotland is where Falkland Palace is, rather. It's a 13th century building, stone built, I must add. But what's interesting about Falkland Estate is they're looking at a community ownership model, and within that community ownership on the estate, looking at the delivery of their built assets using the local timber resource. So they have a timber resource there, and how it could correspondingly be used to deliver their built assets. And some of those built assets on that estate are to be off-grid recreational units, bothies in the Scottish terminology, or huts. And that's a simple form of accommodation, as I say, only to be used for recreational purposes, internal floor area under 30 metres squared, and correspondingly has relaxed planning consent and building regulation requirements. So they're relaxed in order to allow these to be built without full planning approval. And Ninian Stewart, who's the trustee of Falkland Estate, is very much behind this in a movement in Scotland to introduce sort of 1,000 huts around the Highlands and other sort of off-grid, shall we say, areas. So our innovation intervention with this particular project was to create a digital model of the hut and a building information model. So using SketchUp, we had students through the Built Environment Exchange process create that building information model using SketchUp supplied by Trimble, as I say. And why that's really useful is it allowed the students, or our students, to then create panels to articulate the panels for that fabrication. Because these huts have to be ideally to be erected on site by unskilled workers, i.e. the public, who want to have a recreational hut. So if you can pre-manufacture the kit of parts off-site, and the work that we did was therefore, within that building information model, was to put simple things like the density of the material in there, so you could therefore understand the individual weights of these panels to facilitate manual handling. So they're under 50 kilos individually. And we also worked on the detailing of them to allow those parts to come together in a simple manner. And once they're erected, then obviously the individual can customize that through what types of insulation, internal lining, and external cladding. So mass customization in effect through a standard kit of parts. So that was the third case study of the GSD students. We then traveled further north and we visited the BSW Timber. So BSW are the largest sawmiller operating in the UK, and they also have sawmills in Latvia. And we wanted to go there to really focus in on sustainability, because there's not many industries that really have a zero waste policy, and that's exactly what BSW Timber do as a sawmiller. So they don't waste anything. So we wanted to take the students there so they could understand the industrialized processing of logs and how those logs are then turned into products without wasting any of the resource, and at the same time planting more trees than they're removing. So we took, or BSW indeed took the students around the sawmilling facility so they could understand the fullness of the supply chain. What's useful about that as well is that BSW are obviously representative of the sort of UK timber market. And in that regard, what we're able to therefore understand is the level of material that's utilised from the sawmill into construction. A lot of the work that we do at Edinburgh Napier is to try and enhance that 20% margin in order that more timber is used for construction purposes. And a large reason as to why we do that is because that then chimes with the paradigm of the circular economy. Because evidently, the more timber that we can utilise in the built environment, then carbon can be sequestrated for longer and locked in. And it's really at the end of life as such that we should be thinking about the utilisation of timber to produce or to generate power as such. So as much of that material that we can lock into the built environment, to my mind, the better. So a lot of the work that we do working with the sawmills is to facilitate how they can move forward into the circular economy. And obviously, what that therefore requires is once you have the timber and the sawn timber, take into consideration design for manufacturing assembly, and of course disassembly, such that you can reuse that material at end of life. So in this respect, what we've been doing a lot of, and indeed colleagues that I have at Edinburgh Napier, is to look at our resource and what limits its use. And often what limits its use is the preconception that it's of perhaps lower quality than than imported resource. And our resource is generally stiffness. So in terms of grading criteria, it's stiffness limited. But what you notice, although it's stiffness limited, it actually has a higher density and a higher strength properties within that grading class. And if you think about timber design from a structural standpoint, it's often connections which limit the performance of the system. And obviously, if you have a higher density, then you have a higher strength and stiffness of your connections. So if you can therefore utilize that higher density within your design, then you'll get an uptake in terms of performance and correspondingly a better utilization of the material. So you would have further optimization. So hence why we've been undertaking work in this regard. And C16 Plus is now a recognized grade of timber within the UK. Moving on from BSW timber, we then went further north up to Carbon Dynamic, and we visited they're a volumetric CLT manufacturer primarily, but in this instance we wanted to look at digitization, and within that we got the opportunity to further understand the work that they undertook to deliver the Dyson Institute of Engineering and Technology, and how standardized volumetric CLT units were used in an array of 78 modules rather, to create their student accommodation block. Our students, through the sort of BEX process, were able to, as you can see, draw these in SketchUp and create a sort of animation of how those modules were utilized within the site. And the different colors designate the different sort of use classifications, so yellow being the accommodation units. Interestingly, with Carbon Dynamic, they've further enhanced these digital modules to the extent of virtual reality and augmented reality, taking that on board towards augmented worker. So again, there's a skills context to it. The work that we did with Carbon Dynamic in this instance was a lot to do with the necessity for the design and the want to cantilever these volumetric CLT units and correspondingly push the boundaries indeed of, even where the regulations would allowably take it. So what you're seeing there is a sort of student party, I guess, in the bathroom, where you've got a whole series of individuals piled up, creating quite an extensive crowd load. And what was needed was to understand what that would equate to in terms of deflection for serviceability criteria. So in order to do this, what you see in the right-hand side here was obviously to model that was then to think of that in terms of point loads at the end, and then look to create a test setup where you could apply a ratchet to the end of the cantilevered box, so you could understand what that deflection would be. And the reason why we did that was because then they undertook a full-scale test of the system, and you can see one of our proud students stood there, Rory Doak, who undertook the modelling of the system under our supervision support, and we were able to correlate, through dial gauge measurements, the actual deflection relative to the predicted deflection. So in that respect, what you're able to do is create a feedback loop to the digital model to understand the structural attributes. And then you can see the fourth case study that was taken on by the Harvard GSD students in the Dyson Institute for Technology project. And you can see quite categorically that the cantilever is working. So we've touched on productivity, and that was very much the last leg of the tour. And this time thinking of productivity slightly differently. So thinking about productive use of land. And in Scotland, we have a lot of vacant and derelict land sites, which happen to be in urban areas. So it's thinking about how these brownfield sites or discarded sites could be used for productive use. There's 12,000 hectares of vacant and derelict land sites, or 3,600 of them. And there's a task force in Scotland, which I happen to be part of, which is geared towards trying to half the number of vacant derelict land sites and bring them back into productive use, so we're not eroding the green belt all the time. And the vacant derelict land site that we looked at was right in the heart of Edinburgh. So if you know Edinburgh at all, then that's the Royal Mile, so that takes you up to the castle, and that takes you down to Holyrood Palace. And here is the main train station, and then in here is the vacant derelict land site, situated directly behind a hotel. So I had logistical challenges. But what we did was we conducted something which we call mutual placemaking. So that's an immersive workshop working with our creative industries department, where our students and the GSD students undertook a design thinking exercise. And what's key to that is community engagement right at the start in order to inform the design solutions. And we challenged the students with, over a 24-hour period, to create a physical model, a digital model, and a short film of what could be done on that site in order to bring it back into productive use. And bring together architects, project managers, structural engineers, civil engineers together right at the very start with the community to evolve those solutions, utilizing the learning that has come from the week. So in that respect, the students rose to the challenge and indeed came up with some solutions. And what's obviously quite apparent here is, as much as it's in an urban context, there's a lot of green space that's been kept around it, because obviously that's what was being spoken of from the community engagement piece. But of course, using off-site modular timber construction units for the delivery of that. So I think what was really useful from the week was looking at each of the drivers through the lens of the different industry partners and thinking about how industrialized timber construction and off-site construction can respond to it. And from that, what we really see is industrialized timber construction can provide a clean tech solution to the delivery of the built environment. I don't think we would disagree with that. Culture of the built environment should be created in a manner which delivers sustainable communities and wider cultural impact. So thinking about the social ramification of what it is we want to deliver in the future. A digital thread can be realized from forest floor to built asset with a feedback loop for continuous improvement within the realms of lean. I think in terms of regulations, a lot of our innovation is actually almost like driven by regulation. So it's like regs actually pull the innovation through the system. How can we reach the next level of thermal requirement of the building envelope? But why isn't our innovation actually driving where the regulations are being set? And that's something that, circling back even to what they're doing in Vienna with the robotics and how that's challenging structural codes of practice. So there's scope for that. Productivity, not simply thinking about it in terms of increasing output, because we have to think about the generations of the future. And in terms of human capital, it's key, I think, to engage with the consumer, because in so doing so, they can actually challenge what we want to do and, again, pull innovation through the system. So just to close off, what I would say is the exhibition content that's outside with the GSD students have done an admirable job in producing. We've also produced exhibition content which is displayed in Architectural Design Scotland. And if you go to the boards that are outside, there's QR codes. So if you scan the QR code, you'll get further information on the projects. And indeed, our exhibition is digitally enabled, and a large part of that is to try and engage the wider public with what we're doing. We have to tell them what they're doing in order that they want what we produce at the end of the day. So that was absolutely key for us in terms of an output from this process. And that exhibition will be there until the end of January. The case study content will also be included in a forthcoming book. And again, a shout out to Peggy for helping with some of the content for that. Shout out to Ryan for his help in reviewing it, and also to Ivan for the case study on Japan. So thank you to those guys. So that book will come out, and the publishers have offered very kindly a 10% discount for those that are here. So I'll leave that up for a bit in case you want to take a photograph. Okay. And then just my final slide is to say that if you want to learn more about what we're doing in the Scottish context, then working with Ryan and Ivan, we're looking at a ModX tour of Scotland. And yeah, I don't think we need much more of an invitation rather than to say that on that tour, the intention would be to visit the Macallan Visitor Centre, which is a whisky distillery visitor centre which was pre-manufactured from wood. So yeah, I think if we could actually think of a possible better use for timber, then it probably is whisky barrels. And if you're buying a malt whisky that's, you know, if you buy an older malt whisky, then obviously those whisky barrels have been sequestrating carbon for longer. So I think on that front, there's probably a few things that we could learn over a dram in Scotland. So if you are interested, please look this up and register your interest. And with that, I'll thank you very much for your time. Thank you.